Hello viewers, welcome to you all in this new video lecture on MCCB. MCCB stands for Molded Case Circuit Breaker, and it is different from MCB, what we have discussed in the last video lecture, that is Miniature Circuit Breaker. I'm Dr. Vijaysharma, Assistant Professor in Department of Physics, Government Mahila Engineering College, Ajmer. Let us take a look what are the video contents of this video lecture. In this video lecture, we will first discuss what is a MCCB, construction of MCCB and its working principle, and the types of MCCB. A molded case circuit breaker is a type of electrical protection device that can be used for a wide range of voltages and frequency of both, that is 50 Hz and 60 Hz. And this MCCB, molded case circuit breaker, are a type of electrical protection device that is commonly used when load current exceeds the capability of MCBs. So in application part, wherever MCBs are not suitable, we need a standard device, and that device is known as MCCB. In general terms, this MCCB's current ratings are very high. We will see the exact values of the current rated value in the next slides. Meanwhile, we have to see that the function of these MCCBs. Okay, so as the most of the types of circuit breaker works, MCCB also has three main functioning. First, it protects us against overload. It protects against electrical faults as well as it's switching a current on and off. So in case of protection against overload, current above the rated value that lasts longer than what is normal for the application. Protection against electrical fault gives us that during a fault such as a short circuit or a line fault, there are extremely high currents that must be interrupted immediately, and that is done by this MCCB. And switching a circuit, and this is a less common function of circuit breaker, but they can be used for the purpose if there is not an adequate manual switch. So the wide range of current rating available from MCCBs allows them to be used in a wide variety of applications, and these MCCBs are available with current ratings that ranges from low values such as 15 amperes to industrial ratings such as 2500 amperes, for which MCB will not work. So this allows them to be used in both low power applications as well as high power application. Now let us take a look what is the construction of MCCB. A MCCB consists of these following parts. So these are the parts of a MCCB. Let us take a look one by one how these parts actually operated. So the first part is the arc shoot. You will see here that this is the arc shoot here, and whenever a circuit breaker interrupts current flow, an arc is created, similar as in case of MCB. So the function of the arc extinguisher is to confine the divide that arc, thereby extinguish it. And each arc extinguisher is made up of a stack of steel plates. You can see here these are the steel plates, and these are held together by two insulating plates. So they will be connected with the two insulating plates. Next part is the moving contact. You will see here this is the moving contact here in form of this copper shoe. So an electrolyzed brass material, and it is used as a moving contact. So you will see that this is a moving contact here, and the material of construction of this moving contact, it should be of a high arc resistance and corrosion resistance and with a low resistivity. And this moving contact decide what will be the lifespan of MCCB, for how much time duration it will work in a good manner. Operating mechanism, and the operating mechanism of this MCCB means to open and close the contacts. So the speed with which the contact open or close is independent of how fast the handle is moved. So this is known as quick make and quick break opening. And the technique, this technique is known as quick make and quick break. And the breaker cannot be prevented from tripping by holding the handle in on position. So this just by putting it in hold position, it will not be prevented by tripping. So this is known as trip free. And the handle position, this handle position indicates the status of the contact close, open or trip. When the these contacts are tripped position, the handle is in the midway position. This is the just by looking this handle position, we can find out what is the condition, whether it is tripped on and off. So to restore services after the breaker trips, the handle must be moved first to the off position, that is upward, and thereafter it will be again put at the center position. Then the handle must be moved to the on position when breakers are mounted in a group, as in panel board. So distinct handle position clearly indicates the fault of the circuit. So if there are number of MCCBs put in a panel, just by seeing the position of this handle node, you can decide it is faulty or it is healthy. And another part shown in here is the base cover, and it is similar as what we have seen at the time of MCB. The function of this base cover of the frame is to provide an insulating housing to mount all the circuit breaker components, all the circuit breaker components, and the frame is often of glass polyester material, or it may be thermo set composite resin that combines roughness, rigidity, and the high dielectric strength in a compact design. And the frame is also known as molded case, and that is why the name of this device is molded case circuit breaker. Another part of this MCCB is the terminal connector, and the terminal connector is the bolt assembly, and it is made up of steel. So this is generally made up of steel, and it is used to connect the external circuit or wiring with the MCCB. And this overload trip, you will see here this overload trip, and it is a temperature sensitive component, and its composition, it is also composed of steel and copper material, and it is a bimetallic contact. So this bimetallic contact is assembled in series and with the line current, as in case of MCB, and the full current of the breaker will always be passed through this this overload trip current. So it is used to trip the breaker under an overload condition. There is an handle knob. We have already discussed whether its position will decide whether it is in tripping condition, it is on off, or it is on on position. There is also a button shown in here, which is shown in this red color. And this is a manual trip button, and it is mainly used to trip the breaker manually for testing purposes. So this is all about the construction part of this MCCB, and this is deliberation of all these. You will also see that there is a current transformer and trip unit assembly will also be given in here, and it is a set of transformer mounted inside of the breaker, and the output of this current transformer. So these are the current transformers shown in here. It is the assembly of this current transformer, and it is connected to the relay tripping, and it is the brain of the MCCB. It will decide, it will give the signal for the tripping, and the tripping unit contains there is an electromagnetic coil associated with the tripping plunger, and whenever there is this electromagnetic coil is used to trip the breaker with a predefined time delay during a short circuit, earth fall, and instantaneous fault condition. So it will work in the same way as the plunger hitches the latch in the time of MCCB. Now let us take a look of the working principle of this MCCB. The MCCB working principle is very simple, and let us take three different fault condition in which MCCB operates. That is overload, short circuit, as well as the earth fault condition. And in overload trip, in the first condition, overload trip, a flow of current that exceeds the rated current with predefined time limit such as a fault is called overload. Actually, it is not a fault, it is just a condition. So this overload protection is accomplished by means of a thermal mechanism. So we will see here the thermal mechanism, and the MCCB, as we have just seen the construction part, having a bimetallic contacts, and that expands and contracts in response of change in temperature. So whenever there is a change in temperature, there will be a deformation in this bimetal structure. So the bimetallic contact involved in overload operation of the breaker under the normal condition. So you will see this is the normal condition here. So under the normal condition, it allows the current flow. But if the current flow exceeds the predefined value, then it will get banned, and finally it will engage the tripping mechanism. So you will see here that in this normal condition, so in normal condition, what you will see that this is connected with this latch. But in case of overload current due to the due to the temperature variation, this bimetal element it bends. So whenever it bends like this, and due to this bend like this latch is shown in here, this latch will be open, and this will disconnect the circuit. So it will trip mechanism opens the breaker. So this is how this bimetallic contacts functions. So this bimetallic contacts will not allow the breaker to reset instantly. You will see find here, since it takes time to reach the metal to its original state. So this is the one of the type of tripping of this MCCB. The another two type consist of this short circuit, and in this short circuit, an electromagnetic coil involves short circuit, instantaneous protection, or earth fall protection. So under normal conditions, the current transformer generates less current, and hence the electromagnetic field generated by the coil is not enough to pull the plunger, and therefore the breakers does not trip. It is in general case. However, you will see that during short circuit of instantaneous fault condition, the current transformer generates strong magnetic field, and hence the coil pulls the plunger and it will trip the current instantaneously just by pulling the latch. So the typical setting of short circuit time will be 2.5 times of the overload setting, and the time delay will be 0.2 to 0.5 seconds nearly. Another type is the earth fault leakage strip, and this earth leakage protection is quite different from other protections, and it is a tailor-made one. It requires additional current transfer, which has to be installed in the molded case circuit breaker, and the output of this current transformer will be connected in star circuit, and under normal conditions the current flow through the star's neural point will be zero, and if the leakage found in the lines means the same will be sensed at the star terminal. If the leakage flow is higher than the allowable limits, the MCCB trips the circuit. So these are the three ways by which we can trip the circuit and this MCCB operates. Now let us take a look the different type of MCCBs. The MCCBs can be categorized in type B, type C, type D, type A, and type Z, and they are classified in terms of their operating current, their operating time, and their application and suitability. So type B MCCB trips between 3 and 5 times of rated current with the operating time 0.04 to 13 seconds, and it is generally used for domestic application for lighting and resistive elements, and it is suitable for resistive load applications. Type C is having operating current, and it is 5 to 10 times of rated currents with a very low operating time of 0.04 to 5 seconds, and it is used in commercial industrial application, and it is suitable for inductive load applications. Type D MCCB having a 10 to 20 times of rated current, and you will see that its operating time is more less in comparison to about 2, and it is just 3 seconds, and it is generally used for high commercial application as well industrial application where pumps, motors, large winding motors, etc. are used, and it is suitable for inductive as well as capacitive load applications. Type K and MCCBs are having rated current which is 8 to 12 times of rated current, and its operating time is again 5 seconds. It is also used for industrial application. It is also having suitability for inductive and motor loads with high inrush currents. And the type Z MCCBs are having 2 to 3 times of rated current with a operating time of 0.04 to 5 seconds. These are highly sensitive to short circuits, and are used for protection of highly sensitive device such as a semiconductor device, and they are generally used for medical instrument. So in summary, what we can say that these MCCBs are fundamental components of electrical component, and they are used for high current applications or whenever adjustable trip setting is required. So this is not accessible with the MCCB. So adequate sizing and maintenance of MCCB are key elements in order to guarantee safe and reliable operation in the long term. So this is all about the MCCBs. So wherever MCB is not used because the current rating of MCCB is very low, we require MCCBs to be used. So this is all about the MCCBs. These are the references, and thank you for watching this video. For any query, you can write me to my email vijaysharma@gwec.ac.in. The related article with the series of the switchgear you can found on these links. Thank you for watching this video. Thank you.